So today's project is getting electrical in and out of the power shed. You've watched the video where we've done, part 1, 2, 3, and I think 4 on building the actual shed, which would actually, work for a storage shed or anything else. We're using it for a power shed for all of our solar equipment. So we've gone ahead and insulated it and actually put up cedar V-match, some we had left over from the woodworking shop. So you'll see, it's a little hard to see. The room is very small. It's 8 by 8 on the outside. So it's more like 7 by 7 on the inside. It's big enough for what we want it for, but it's hard to see with the camera. But when we're all done, this wall behind me will be, this is the utility power from the utility grid. This is the load center that will be fed by the battery-based system and feeds all of the backed up loads in the house and the garage. And then over here beside me, there'll be a Snyder XW6848 Pro that we'll be putting in. We'll be putting in our Fortress lithium battery underneath that. And then over on the side wall here, we'll have a big battery combiner box where we can change the batteries because we have a set of lead acid batteries we use. We're going to be doing some testing on some batteries from the Alti store and some batteries from Midnite Solar. And then right behind you guys, the wall that you can't see, that I'll spin you around. You'll notice it's not even done yet. This is going to become the fireproof wall. We're going to plywood this wall and we're going to put sheetrock on that wall. And that's going to be where we do all of the testing on all the new Midnite products, the inverters and the charge controllers. And all that prototype testing, all that stuff will go on that wall behind you. The wall behind me will be like kind of the standalone fail-safe system that always works. And then what we'll be able to do is we'll have a couple breakers in here that are handle tied, so you can only turn one on at a time. And what will end up happening is if we want to test the Midnite inverter behind you, we'll turn that breaker on to feed the house and we'll turn the breaker off that feeds the XW. So we'll be able to change it all around, but yet keep it functional for what we're doing. So what we've got here is we've put in our 100 amp load center, 2 of them, and I'm going to see if I can get you a little better lighting and a little better view, and we'll be right back. So hold on one second. Okay, so we're back. Apologize for the lighting in here. Again, it's a temporary situation. We will be putting in a 12 volt system with some 12 volt LEDs that we'll do a video on. But what you got here is you've got our 100 amp sub panel that is being fed from a panel in the house that's from the utility. So it's a 50 amp breaker in the house, feeds a piece of 8.3 Romex out to this panel, providing this panel with 120/240 at 50 amps. You'll notice there's another black wire that comes up through and a white wire that comes up through there that are hanging down in front of the camera. That's basically for going back into the house, and we'll talk about that in a minute. You'll notice we've put our ground bus bar in over here. This is like I said, you have to ask for that. So when you go in and buy this sub panel at your electrical supply house, and like I say, you have to ask for this ground bus bar. When you go in to buy this sub panel at your electrical supply house or your favorite big box store, it won't come with this ground bus bar. You have to actually buy that separately, and then it installs. There's a variety of different places you can put it. I chose to put it over there on this one. You'll notice up top I put it in a different place. We did put in a convenience receptacle right down here that is powered from the grid, so we'll have power in here like if we want to run a heater or something while we're in here. We don't plan on heating this. We believe that the solar equipment will keep it plenty warm. And another thing I talked about was if you were going to use this panel as a main panel, which you really can't because there's no main breaker, but this is that green screw, and that screw would go right in this hole and it bonds the neutral to the metal chassis. So the reason I point this out is because if you're doing an install where it needs to be bonded, this needs to be put in, otherwise this chassis floats, and if it ever gets electrified for whatever reason, it can cause a problem. So now we're going to back you up just a little bit. We're about there. Okay, so up above here, we have the same exact panel, but this is actually going to feed the house. So this is going to be powered from the inverters and send power back into the house. Now, in a typical solar install, you wouldn't need to do probably either one of these. You could feed that wire right into your breaker panel, which you'll see us do later in another video. And then this wire going back to the house could come right from your breaker panel on your inverter. But because we want to be able to change out inverters and test equipment, we wanted utility and we wanted feed out here. So what we're going to do now is we're going to go ahead and make up the panel up here. We're going to get the smoke detector wire, which I didn't really talk about, but what we've done, because there will be a lot of prototype equipment out here, we've actually ran a 3-conductor wire into the building, and that will be tied into the smoke detectors in the wood shop, the garage, and the house. So if there's an issue in any one of the 4 areas, all the smoke detectors will go off. So you'll see the video, I'll try to leave a link down below, but there is a video we did before where we wired up the smoke detectors, we roughed them in the wood shop. So we'll do another video specifically about the smoke detectors, but that's just going to mount right up here above this panel in a little box. So we're going to go ahead and get these wires out of the way and let you watch this. Hopefully you can see what we're doing. I'm not, getting in the camera's way, but we'll probably just... And a lot of this is probably repetitive because you'll notice there tends to be a lot of electrical videos going up on our channel. And so I'll tend to say the same thing multiple times, but I'm not sure that's really a bad thing. So it's good to find out the little things like the square drive screwdriver. See if you can see that. All your connections in your electrical panel, including your cover screws, have that square drive fitting on them. And it's much easier to deal with. Than your typical flat-bladed screwdriver. And I said all the connections. The main lugs up here take a flat-bladed screwdriver. They do not take a square drive. And I don't think there's a right or a wrong way to which goes where, red or black. I like to keep mine all the same, especially in the solar system, because when the relays switch in and out, rather than going 180 degrees out of phase or whatever, everything's the same. And I like to stay black first and red second, and that's mostly just because black is your first hot conductor, red is your second hot conductor, by choice. So the other thing I'll point out too, these covers only have 4 screws. A lot of the covers, maybe you see it up here, these covers have 4 screws, 1 in each corner. The bigger panels have 6, and you want to make sure you don't get any wire right there, because the screw going in and out will eventually wear through the insulation on the wire and cause a short circuit. Okay, so that's all done. We put our ground in our ground bus, our neutral in our neutral bus, and we put our line 1 black in the left-hand lug, our line 2 red in the right-hand lug. You notice there's nothing in the neutral lug because we're using 8-gauge wire. It's a 50 amp circuit coming out. 8-gauge wire is perfect for that. So we go ahead and went down here where it's just easier to connect it, and we didn't use that big lug. So what we're going to do now for today is we're going to put our smoke detector wire inside the panel like that, just so that we're not fighting that panel. And then we're going to go ahead and we're going to install surge suppression. So this would be put typically anywhere in the system, usually as close to the utility as you can get. I do have them there, but because all the expensive stuff's going to be in this shed, we're going to go ahead and put our surge suppressors out here as well. This particular one is made by Midnite. It's what they call an MNSPD-300-AC. And it's meant to protect 120/240. So we're going to go ahead, and there's a parts kit here. If you're using it outdoors, there is a silicone washer right there. See if I can show you that real well. That would go up against the SPD, and then the SPD would go through the housing, and then your lock nut would go on the inside. If you were using it in a DC application, they include this little piece of white heat shrink, so you can change the black wire to a negative. We're not using that here. We're going to set that there. We're not going to use the silicone washer either because we're inside. So then what we're going to do is we're going to look at this. We're going to uncoil our wires. And we'll give you a little rundown of what it is, how it works. So inside there, you can see them right there. There's the 2 blue things. Those are called MOV, metal oxide varistors. And basically what they do is they act like brake pads on your car. So this has a red, a black, and a green wire. So what it's doing is there's one of those MOVs on the black and there's one on the red. And they're both going to the ground, the green wire. So what an MOV does is it's a voltage rated device. So when it hits a certain voltage, it starts to conduct across. So if the black wire goes above a certain voltage, it will start conducting to the green wire and try to clamp the black wire down. And on a 300, let's see if I can find that information for you, but I believe it's around 500 and something volts that this starts to clamp to ground. And you're probably thinking, wow, that's scary. That's a lot of voltage. But something you have to remember and realize is that every piece of electronic equipment you own in your house that has a stamp on it by UL or ETL or whatever testing laboratory has had to go through a high pot test. And a high pot test tests it up to 2,000 to 3,000 volts for a few seconds. So that momentary spike is low enough that it's still very safe for the products. And any surge suppressor works that way. It's not just the Midnite one. That's the general basics of your Square D, whole house surge suppressor, the Midnite one, Cytel, Cutler Hammer, anybody that makes one of those, they all work basically the same way. And so like I said, what it's trying to do is it's trying to take the black wire and bring it to the green wire, and the red wire and bring it to the green wire, to keep the black and the red wire from exceeding a safe working voltage. So hopefully I did that justice, but now we're going to try to figure out where we want it. We was kind of thinking about it in there, but it doesn't quite fit. I think we're probably going to end up going probably right there on the side. I don't know. Let me see if I can get you down there where you can see that. There you go. This particular panel has a knockout right here on the side that I think would be a great place for it. I thought about right there too, and I just think it's going to interfere with the receptacle. You're not seeing that real well. Let me get you down there. Sorry about that. I was thinking about putting it down there, but it's kind of going to interfere with everything. So I think this is the logical place over here, and it's away from all the equipment. It's out of the way. So what we're going to do is we're going to take our T-strippers, and we're going to punch this knockout out right there. We're going to push our wires back out of the way. And there's our knockout. We're going to go ahead and bring these wires in. going to put our nut on. The nut is a little bit dish shaped. I'm not sure I can show that on video. And the dish wants to face towards the panel, if that makes sense. So the teeth are pointing down, and that way they bite into the metal. And one of the ways I like to tighten these, you could get a screwdriver and a hammer and you could turn the lock nut and tighten it. But this makes a pretty good handle right here. So you can just hold your nut with your fingers and you can turn the lightning arrestor until it's snug. You know, you don't want to get crazy with it. And if you're doing it outside, you want to watch the silicone washer. If you go too tight, it'll actually push out the side and you'll lose your seal. So just be aware of that. Now on this one, we kind of want the ground wire. We don't want any of the wires to have a real sharp bend. So one of the things to keep a mind of is when we're dealing with lightning, it doesn't like to take sharp bends, or so I'm told. I've never actually watched it myself. I've seen it do a lot of damage. So we can use that to our advantage in some places. Like if we're running a wire down, say, a tower from an antenna. You can make a big circle and then go, you know, back into the house. You come down the tower, you make that circle like that, make a couple circles, and go back into the house. And if lightning is actually on that wire, they say it'll blow it out the bottom of it and it won't chase it around into the house. But the same issue happens here. We want to make sure that we don't make a real sharp bend in these wires. So if there ever is lightning on them, it'll try to chase right straight back. Now that said, you know, if you take a direct lightning strike, kind of all bets are off. But 90, well, I'm not even going to put a percentage on it. I'm going to say probably a majority of the damage caused by lightning is from induced voltage getting into the equipment from a nearby strike. So, you know, we've got, on this wire here, we've got 125 feet of wire here. So if lightning hits a tree, you know, 500 feet, you know, whatever, somewhere in the general area, let's say lightning hits a tree, there's a lot of induced voltage in the whole area. And what happens is this wire becomes an antenna and it picks up that magnetic pulse, that electric pulse from the lightning bolt, and it induces into the wire and creates voltage. So by doing this, we're keeping that down on both ends and keeping it safe for the product. So my general rule on these things is if the wire is over 500 feet, 50 feet, and there's something on that end worth protecting, I put it on there. If we're going 50 feet out to a storage shed, and there's nothing in the storage shed other than a couple lights, I probably don't worry about it. If you're putting thousands of dollars of solar gear in it, probably want to put one in there. So now we're going to find us a breaker. I believe if you read the Midnite information, they recommend a 20 amp breaker. We're going to go ahead and install that. And on your breaker, there's a couple little holes right there. Let me see if I can get you a couple little holes right in there. And they lock right into these spots in the panel. And then it rolls onto the tabs like that. We're going to make sure the breaker is off. We're going to go ahead and same thing, we're going to keep these wires pretty short. We're going to go ahead and go right to the breaker. And something I'll point out here, I'm not sure just how visible it is. Let me bring you on a little closer. There we go. So you'll notice up in here, if you look closely, you'll see a little bit of copper showing above the lug. On the side of my breaker over here, you'll see a little bit of copper showing. I always like to strip my insulation back, maybe 1/8 of an inch, 3/16 of an inch more than is needed, so that when I look in there, I see, for example, right there, I see the copper between the bus bar and the green. So I know that I didn't accidentally pinch my insulation under the terminal and not get a good connection. So now we're going to turn this breaker on. And now we're protecting this panel and everything downstream of it out here with our surge suppression device. You'll notice it's got a blue light on right inside it. There's actually 2 of them. One of them you can't see on the back side here. Those are telling us everything's good. If you don't see the blue light on, that's telling you the unit has failed and you need to call support. These things come with a 5-year warranty against anything. So if you take a lightning strike and this thing explodes, Midnite will actually give you a new one, no questions asked. So keep your receipt when you buy these. They do come with a 5-year warranty. So what we're going to do is we're going to actually go ahead and wrap up the video here. We're going to get the lightning arrestor in the top panel the exact same way. So you probably don't really need to watch that. And then we're going to go ahead and come back and start mounting a inverter and what we call an E-panel. It's made specifically for the inverter. It's where we do all of our DC and AC connections, all of our breakers. And then we'll be moving on to charge controllers and batteries and all the fun stuff. So don't forget to like and subscribe and come on back and watch us install the inverter on the wall. Fun fact, it weighs about 160 pounds. So